Hey, today let's discuss how do we connect to a remote SSH server. So basically when you have a machine A and you want to connect to a remote computer, let's say it's a server or somewhere, a computer which is somewhere else, somewhere on the internet. So the secure way of connecting to that is using something called SSH, secure shell. It's called a secure shell, I believe. So there are two different parts to it. One is the part where you generate these keys, which are used for authentication. And second is the part where you actually use them. So let's go through the entire part today. I'm also making this video because I tend to forget these steps. So just trying to document everything on a high level so that it's useful for other people as well who face the same issue. So the way this works is, let's say I've created an account in Linode. This is the way I would create an account. I would click on create. I would give an OS which I want. I would give a server. I'll say what is the specs of the machine I need, and then you would add a password to this machine. This is used for this is like how you enter a password ID, right? That's one way of authentication. I just put a password as a remote password. I would also add SSH keys. Using SSH keys is a different way of authentication. Using a password is another way of authentication. I've explained it here. So you see here, to use the SSH key, there are three ways, right? One is, let's say you actually enter the password which is entered here. That is one approach. Second approach is where you actually just give it the path of your SSH key which you have added here. And that's how it will just ask you the passphrase of the thing. I will come to this part. Let's go into this part in detail first. So let's say I create this. Here I've already done a step. So this is the IP of my machine. It says so the way you can access this, right, usually is what is the username you want to log in as. That is the part before the @ and then after that is the IP address of the machine. So normally if you go to any website, let's say google.com, this is called a host name. This is a more readable way of accessing some server's IP address. Actually this resolves to some IP address internally. So since it's not easy to tell someone, right? If you want to search on Google, just open this 192 whatever, some URL, some IP address. So another easier way of accessing it is if you have this behind if you have a DNS, if you want some domain, you can say that google.com has to point to this 192.46.215.87. So that way you can just enter root at google.com. That could also work. So I have also mentioned the other ways of accessing a server here. So if you see, one is the username and then the IP address which we saw. I also discussed this other one, that username the host or the domain name. There's also one more way. You write an alias and put it in your SSH config, so that it makes it easier to connect to some instead of writing the whole thing again and again, right, from memory or copy pasting it. One more easier way. I will show you this towards the end. So let's go back to this. I have created this. Let's say what are the different ways I can connect, right? I've showcased them in this image. First is, let's say I just put SSH and the thing which I gave. The thing here is, by default, I have a particular SSH. If you go to my SSH folder, these are the paths, okay? I'm not using the default one. So it will tell me that, okay, the SSH key which I've used by default is not working. So maybe you want to connect with a password, because the SSH key authentication is not correct. So it will say, okay, give me the password. In this case, I would enter the password which I have entered here, the root password of the machine, or the password of the machine basically. This is one approach. I'll enter the password, so remote password, and it will log in. The problem is that these things here, right, they need some some secure password which has uppercase letters and numbers or something or the others, special characters. It's very difficult to keep typing this complex password every time you want to use this. There's another way of doing it, wherein, let's say I created a SSH key. I will show you. I'll not go too high in depth into actually doing these exact steps of generating SSH key, but towards the end I will tell you high level how it works and what does it do actually. So let's say I have SSH key. SSH key actually consists of two parts. One is a public key and one is a private key. Public key is like someone's post box, right? That post box, anyone can come and put a letter in it. but the person who can open that post box is only the owner of, like the owner of the post box, which is the who has a key and he can open it. That's like a private key. So SSH is sort of like a asymmetric key cryptography. Cryptography is a way of encrypting, decrypting data so that only people who are intended to read information can read it. I will come into a specific example later on. Let's go ahead for now. So here I would say the public key is what I would give on the server. So let's say if I am communicating with, I'm using SSH to connect to GitHub, right? So GitHub will ask me to put some key in the inside GitHub. The key which I'll put over there is called a public key, and the key which I would put on my machine is called a private key. So same way, let's say I say that okay, SSH and -i is the identifier, and I give it the path of the key which I want to use. It is ID ED25519, and that's the encryption algorithm or the hashing algorithm, I think. And then the name of the file, that's _linode. That's what I've given when I created the key for this. So basically I give this key, and then I'm able, it will ask me the password for to use the key. So each key can be without a password or with passphrase. It's better to add a passphrase. So let's say I have added my passphrase for using this key, and it will allow me to, it will use that key after that, and then it will say okay, if it's valid it will allow me, if it's not valid it will tell me fail. Next is like, say if you want to use let's say this is also very tedious to write every time, right? Give the whole path and all that stuff. So you can create some configuration which is in your .ssh, that /config file. Here I've given a host. I've said that whenever I say that SSH Linode Mumbai, use these host names and use this username to log in. So this is in a way doing SSH root @ this 192.168.215.887, and it is also going to use this identifier file, which is basically the path which I have given here. So this is an easier way of doing this command. So what happens here is, again it will ask you that okay, I understood this is a short form of using this. Now tell me what is the password of using this SSH key. So then I'll enter the password. That works. Now this is the most optimal thing, but again every time you have to keep entering this this password, right? If I close a terminal instance and I again do it, it will tell me okay, do and enter the password again. So it's very irritating to do this every time. So the way you solve this is using something called as a SSH agent. So you start an SSH agent. So in Windows system you would go to the services and then you would search for this open SSH authentication agent. Here I've set it to delayed start. If it's not started, you will also have to start it for that particular logon of Windows. I've started my SSH agent. I've said SSH add, and I've given the path, that C drive so and so, so and so. So as you can see here, C drive whatever the path. It said, dude, okay, give me the password of this which is required for using this. So then let's say I SSH this key, I close the terminal, but that process is still running of the SSH agent in the background. So now what happens is, if I close that terminal instance and I in some other instance I again try to hit this SSH Linode Mumbai, it will never ask me for the password, because that SSH agent has stored that passphrase for that logon of Windows. Unless I shut down Windows and come back again, in which case the SSH agent will get closed and it will have to start again. So only in the first boot I'll have to do this. If I do this SSH add part, it will ask me for passphrase. Then after that I won't have to do it again. So that's the optimal way of doing it without needing a lot of passwords and all. So now let's go. I hope this covers a high level overview of how do you connect to a machine. To summarize, there's one password way, which is you enter the password when you created the machine. Second way is like using the SSH key. SSH key, the public key you have given to the server already. So you will just give it the private key which you want to use, and to use the private key you need to enter the passphrase if you have entered it. Passphrase is like a password for the using SSH key. Once you say the correct password, it will use it and then say okay, fine, this is correct or wrong. If it's correct, it will allow you to connect, and then you run your commands. And the problem with this approach is it's very verbose, right? To make it convenient, you will set up some things in the config, and you will pass these different things. To avoid having to enter passphrase again, you may use something called as a SSH agent, and just do an SSH add the key, and subsequent parts you will not require to enter the passphrase again. Let's go high level on what is the process of generating SSH key. SSH key usually has this part. You give it a SSH keygen is a command which is used to generate this. This is the hashing algorithm. It's a secure one, so I just use this as of now. -c is a way of putting a tag to the key. So if you go to the config file, you can see that here my tag is, this is my public key, right? This is the tag Linode SSH which I have given. You just give a tag to identify the what was this used for. So on the server also, when you give the key, you can understand, okay, this key is for like my Windows machine, or it is for something else or whatever. You usually push some identifier for the machine you're using it for, going to use it from. Next is like you tell the file name. So here I've given that it's for Linode or something. So here is just an example. If I was using for AWS, I'll say that okay, this key is for AWS. Some identifier of where it's going to the server basically. And I'll enter a passphrase here. It will ask to enter twice so that you don't have any typo and all. Then it's generated. It will generate two things. It will generate this public key, and this is the private key. So next thing, like I said, generates public key, private key. Public key is like the post box, which everyone can see and use and all. Private key is what is stored on the machine very safely, because that's what is the most important thing to keep secret. If you expose this, it's like as good as not having any authentication at all. So like I said, here public key is exposed on public machine. So let's say if I'm using Linode here, I've given my public key to Linode. And I've also, let's say if it's AWS or GitHub, sometimes you do for code, right? You git clone and all. And if you're using SSH, the public key is what you're given you added in your GitHub account. You would have added that public key of yours, and then that's how it's able to use it. And this is you stored on your local machine. So as I said, if I let's say have a zip file, I put a password to it, and I share the zip file to someone else, right? Now say if I have to give them the password on email or something, anyone who has access to the file and to the password can open it. So it's basically the key to open the password is the same. If anyone has access to the key, it will get compromised, the data. So there's a different, that's called symmetric key cryptography, wherein the key to open and to lock and unlock is the same. Whereas if you go to asymmetric key cryptography, there's a public key and private key. So let's say there's a machine A that has a public key A and private key A. Machine B has again its own public key and private key. So let's say I want to send a message from machine A to machine B. Okay, this is the original message. So what happens is it encrypts the message using the public key of the machine B. Okay, so let's say it encrypt the message with machine B's public key. Public key is always accessible, and any server on the internet can have access to this public key, let's assume. So it encrypts the message with this public key here. So this is the encrypted message. This encrypted message is sent on the network. So this is like a function representing that these are the inputs. This is the message, and this is the public key which is used to it. This is B's public key. This encrypted message is sent on the network. So the person anyone who taps it will just know that something has been sent. They will not be able to read it, because to read it you need the private key to decrypt it. So let's say what happens on the B's machine, they have this encrypted message. So they basically run a decryption algorithm on it. They pass the encrypted message and they give the private key of the B, and that's how you get the original message back. So basically they use a decryption on machine B, and since it's asymmetric, right? Originally it was encrypted with the public key of B. On the receiver end, it was decrypted with the private key of the same machine, and that's how they're able to transfer the message on the network without having to worry about this. A person in the middle can read the messages or whatever. So this is a safer way of doing it. So this is a high level of SSH keys and how it works in the background. This is used in multiple places. It's used in like HTTPS for anything in website which is HTTPS, right? The communication in that is using that. There's also like these normal things, right? Connecting to servers, GitHub, you use SSH. So many places it's used. It's very useful, and this is just a high level overview of it. Hopefully you have a good understanding of how the pieces fit together and what happens on a high level. Thank you.